Hello, this is Lecture 7, 6th Sem, Maths-1, Unit-3, Legendre's equations and functions by Ramanjan sir, Department of Mathematics, Tungal College, Jamkandi. This is the Lecture 7 by Ramanjan sir, Department of Mathematics. So let us see the recurrence formulae. Recurrence formulae or formulas or recurrence relations. Next paragraph. The recurrence relations or recurrence formulae can be derived from generating function of Legendre's equations. Legendre equations. Next, formula 1 show that n plus 1 p n plus 1 of x is equal to 2n plus 1 into x pn of x minus n pn minus 1 of x, or suppose n can be replaced by n minus 1, so that npn is equal to 2n minus 1 into xpn minus 1, n plus replaced by n minus 1, minus n minus 1 into p n minus 2 of x. X is to be the variable in the function pn of x or pn plus 1 of x. It was given in examination 2018, either this or maybe this form. So let us see the proof or solution for the formula. We have 1 minus 2xz plus z square whole to the power of minus 1 by 2 is equal to the generating function sigma n is equal to 0 to infinity z power n into Pn of x. Next, differentiate with respect to z. Differentiate with respect to z minus 1 by 2 into 1 minus 2xz plus z square whole to the power of minus 3 by 2 into minus 2x plus 2z by chain rule is equal to, the right side is sigma n is equal to 0 to infinity. With respect to z differentiation means this is constant. Sigma n is equal to 0 to infinity n into z to the power of n minus 1 into Pn of x. Into Pn of x. This implies the above step is to be like this. Next, after differentiation with respect to z, multiply both sides, multiply both sides by x minus 2xz plus z square. So what it will be, the next step? So that after multiplying with 1 minus 2xz plus z square on both sides, the simplification is to be x minus z into it is sigma multiply with this term, that is x minus z into 1 minus 2xz plus z square to the power of minus 1 by 2 is equal to, is multiplying on both sides, 1 minus 2xz plus z square into sigma n into z to the power of n minus 1 into Pn of x. That implies x minus z into, what is this simplification? Sigma n is equal to 0 to infinity z power n Pn of x is equal to, the right side is 1 minus 2xz plus z square into sigma n into z power n minus 1 Pn of x. This implies x minus z into, so what is the expansion of this? It is n is equal to 0 means just 1 plus, next z n is equal to 1, z P1 of x plus z square P2 of x plus and so on plus z power of n minus 1 Pn minus 1 of x plus z power n Pn of x plus and so on. This is all left side of this. Next, right side is equal to 1 minus 2xz plus z square to the power of, z square itself. Again expansion, a sigma is there. N is equal to 0, that is n is equal to 1 first of all. So the 1 into p1 of x plus z p2 of x plus and so on plus z to the power of n minus 1 p n pn, because 1 will be less, this is z power n means 2, so that it is pn of x plus z power n pn plus 1 of x plus and so on. Next, equating the coefficient of z power n on both sides left side, x into pn of x into pn of x minus pn minus 1 of x is equal to n plus 1. Here we can see that this is n plus 1. Z power n coefficient is left side is the next. Of course, the right side we have to take. N plus 1 coefficient is pn plus 1 of x, pn plus 1 of x, because 1 into this term. Next, this into the second term, it is to be minus this is, here is 2x, here is 2x and 2x into, and the n terms are to be cosine reducing here. Even in the step n also we can substitute. N is equal to 1 means the total is 1 z power n, and n is equal to 2, here is 2 into 2z, that is 2 into z p2 of x and so on. Here is n minus 1 into n minus 1 into n minus 1 into z to the power of n minus 1, whereas here is n into. So what we have here is also in the expansion of this is previous term is pn means this also to be n, and this is to be n plus 1 into z power n into pn plus 1 of x. So that here must be as n plus 1. So n plus 1 into pn plus 1 of x minus n into 2x into pn of x plus n minus 1 into p n minus 1 of x. See that carefully the right side step as it is. N term is also there. N is equal to 1 is this, n is equal to 2 is this, and so on. n is this, n plus 1th term is this. The suffixes n, 2, 2. So that n plus 1 is, its coefficient is n plus 1. So the same we are writing here. The coefficients of z power n on both sides implies that n plus 1 term is to be take all to the right side. Suppose this term only this, and take other terms to the left side. So that n plus 1, because we require that n plus 1 into Pn plus 1 of x is equal to 2n, this term 2n x Pn of x plus x into Pn of x into Pn of x, this one, plus n minus 1 into Pn minus 1 of x minus Pn minus 1 of x is equal to the right side simplification 2n plus 1 into xpn minus n minus 1 plus 1 into Pn minus 1 of x. It's also Pn of x, or simply Pn. This is equal to 2n plus 1 into xpn of x minus n into Pn minus 1 of x. Next, so this is LHS is equal to RHS, or replace n by n minus 1, we get npn is equal to 2n minus 1 into xpn minus 1 minus n minus 1 into Pn minus 2. The result will get it. Next, formula 2. Formula 2. So this was given in 2019. Show that n Pn of x is equal to x into Pn dash of x minus Pn minus 1 dash of x. Next, the solution. We know that 1 minus 2xz plus z square to the power of minus 1 by 2 is equal to sigma z power n into Pn of x. This is the generating function. Differentiate with respect to z. Minus 1 by 2 into 1 minus 2xz plus z square to the power of minus 3 by 2 is equal to sigma n into z power n minus 1 into Pn of x. Take this as equation 2. Differentiate 1 with respect to x. Differentiate 1 with respect to x minus 1 by 2 into 1 minus 2xz plus z square to the power of minus 3 by 2 into minus 2z is equal to sigma z power n into p and s of x with respect to x differentiation. This implies z into 1 minus 2xz plus z square whole to the power of minus 3 by 2 is equal to, take this, so multiply with z on both sides, and minus 2 plus 2 will be cancelled, so that only z, the left side. The right side is sigma, differentiating with respect to x, sigma n into, because that value, see, the 2 equation is there. This is differentiating with respect to z, and also we are not writing the one step here with respect to z differentiation. Minus 2x plus 2z, minus 2x plus 2z, minus 2x plus 2z. So that minus 2x plus 2z means that another step is getting, because 2 minus 2 is to be common. Here I will write this x minus z into 1 minus 2xz plus z square whole to power of minus 3 by 2 is equal to sigma n into z power n minus 1 into Pn of x. So from this step, again this, right? So this is 2. So coming to here, differentiate 1 with respect to x. So what it will be? Minus 1 by 2 into 1 minus 2xz plus z square. This step differentiating, minus 2z is equal to sigma z power n into p n dash of x is correct. Next, z into 1 minus 2xz plus z square to the power of minus 3 by 2 is equal to so what it is now, that sigma z power n p n dash of x. Take this as equation 3. So 2 by 3 implies 2 equation divided by 3 equation implies x minus z divided by z is equal to sigma n into z power n minus 1, sigma n into z power n minus 1 into Pn of x divided by sigma z power n into Pn dash of x. This implies x minus z into sigma z power n Pn dash of x is equal to sigma cross multiplication, n into z power n into Pn of x. Compare coefficients of z power n on both sides x p n dash of x minus p n minus 1 dash of x is equal to np n of x. npn of x implies npn of x is equal to x pn dash of x minus p n minus 1 dash of x. So this is the second recurrence formula. So thank you very much.